This instructional video is a continuation of classifying and writing the equation in standard form for the conic section. In the past we talked about ellipses and circles and parabolas. Guess what this is? Let me break out the paper that shows the standard form when classifying the conic section and the rules to identify which is which. If the discriminant b squared minus 4ac was less than 0, we said there's a possibility of being a circle or an ellipse. And what distinguished them was the fact that to be a circle, you had to meet two criteria. B had to equal to 0, and A and the C had to equal. Otherwise, it's an ellipse. To be a parabola, the discriminant had to equal 0. And if the discriminant was a positive number, greater than 0 that is, you knew you had to find the hyperbola. So, keeping this on the side over here, first thing you do is identify the coefficients A, B, and C. A is 9, right there. The A. The B, once again, there is no B. So it's a 0. And C, the coefficient for the y square is negative 4. See? The C is in front of the y square. Now we're going to go b squared minus 4ac, so we can decide what kind of a conic section is this. So b squared is, again, 0 squared, minus 4 times a, which is 9, times negative 4. These numbers seem to come up very frequently. So in this case, negative 4 times negative 4 is positive 16. 16 times 9 is 144. I'm going to remember this in my sleep. And since it's a positive, since it's greater than 0, this is going to be a hyperbola. Hyperbola. The only thing we need to worry about is this hyperbola, is it going to have a horizontal transverse axis? Meaning, is it going to open this way and that way? Or is it going to be vertical transverse axis? Up and down this way. If it was horizontal, the standard form should be written as x minus h squared over a squared. And it's a difference now, unlike ellipse. Y minus the k squared over the b squared, and that's going to equal to 1. That is horizontal. If it's a vertical transverse axis, given that the midpoint is not the origin, meaning h and the k, it'll be y minus the k squared over the ax. The x and the y term switch places. The a and the b, they stay. And the x minus h squared over the b squared is equal to 1. So it's going to be one or the other. So we have to figure out what this is going to turn out to be by using complete the square method. So let's write this 9x squared minus 4y squared plus 36x minus 24y, and let's go ahead and get rid of the constant negative 36 by adding 36 to both sides. So equals 36. Now let's group them. Let's put the x's together. 9x squared plus 36x minus the y's now. 4y squared minus 24y is equal to 36. And now here we go to complete the square. First, let's take out the leading coefficient 9, factor it out. So what we end up is x squared plus 4x. Now, take half the b, half the 4 is 2, and you square it. So it becomes 4. And remember, when we add the 4 to the left side, that's not all we're going to add to the right side. We're going to be 4 times the leading coefficient 9. And that's what we're going to add to the right side. Over here, the leading coefficient negative 4 is going to be factored out. What remains inside this binomial when we enclose it is y squared plus 6y. Negative 4 times 6 is negative 24. But now to complete the square, half of 6 is 3. 3 squared is 9. Once again, it is not just 9, it's going to be negative 4 times 9 that we're going to combine to the right side of the equation. So now that constant 36 was already there, now we're going to add 9 times 4, which is 36. And we're going to also combine negative 36. And we're going to simplify this trinomial into one single term for each of the variable. So we got 9 times x plus 2 squared minus 4 times y plus 3 squared. And that equals, when we evaluate this, these two additive and inverse cancel out. So we got 36. Now, how do I make this 36 become a 1? Like one of these? Well, we have to multiply the reciprocal of that constant 36, which is 1 over 36. And do the distributive property to each of the expression and the term. So 1 over 36 times first expression dx, the 9 coefficient reduces the 36 by 4. So we could write it as x plus 2 squared over the 4. Hey, perfect square. The leading coefficient 4 negative reduces 36 9 times. So we end up with minus y plus 3 squared over 9 equals. Now the constant 36 cancels out the 36, or they simplify to a 1. Now since the y and the x is in its traditional horizontal transverse axis format, we could identify the a and the b. A is the square root of 4, which is 2. The b is the square root of 9, which is 3. What's the focus? The focus is the inverse of the difference. So it becomes square root of a squared plus b squared. So in this case, it is 4 plus 9. And so it becomes square root of 13. What exactly is about square root of 13? Well, square root of 13 is approximately 3.6. That means from the midpoint, okay, between the two vertices, the focus is going to be square root of 13 units away, or 3.6 units away from the midpoint. So approximately 3.6. That's going to help us identify the focus on the graph. And what's the h and the k? The translated midpoint is going to be at the inverse of the 2, which is negative 2 and negative 3. We could graph. So 1, 2, 1, 2, 3. Here's the new point at negative 2 and negative 3. The vertices are at 2 units away from the midpoint. So 1, 2, right there. What's the coordinate for that? It is 0 and negative 3. And 2 units to the left of that, 1, 2. So what's the coordinate for that one? Is negative 4 and negative 3. And how about the covertices? Well, it's not a covertices, but what's the b value? That's going to allow us to draw a rectangle, which will help us identify the asymptotal lines so that we can draw the hyperbola. Almost forgot that word. From here, it's 1, 2, 3 units away. So 1, 2, 3, right there. And so the b value is going to be at negative 2 and 0, and 1, 2, 3 this way. And so the coordinate for that is going to be negative 2 and negative 6. So now we could draw the rectangle. And why is that necessary? So we can draw the matching diagonal lines which represent the asymptote. Remember the asymptote? When we have a horizontal transverse axis, it's defined as y is equal to plus or minus b over ax. So in this case, y is equal to plus or minus b is 3 over 2x. Okay? So if we were to say x is 2 units away from the midpoint, then the y will be 3 units away, which will give you one of the points of the asymptotal line right there. Now, how do I could just estimate the hyperbola and just say, since it's horizontal, we're going to go this way. And going along the asymptotal line, but never actually touching it. Same thing on the opposite side. So there it is. Hyperbola. Going along the asymptotal line, but never actually reaching it. So here's my standard form of this hyperbola that has a horizontal transverse axis. Here are my vertices at 0 and -3 and -4 and -3. My foci, I'm not going to label it, but it's right there. Right there. Right there. That is going to be my foci, focus, which is square root of 13 units away from the midpoint. Same as over here. That's my second focus. Okay? And what is my midpoint? H and K is -2 and -3. There it is. Now if you got that, why don't you try this one? Okay. Now, I hope you were not overwhelmed by this huge number. But once again, we have to identify the A and the B and the C. So A is -9. B, it isn't there. The one with the X and Y term. So it's a 0. And the C is the coefficient from the Y squared, so that's 25. Once we got our A, B, and C, we had to identify the discriminant. So we got B squared minus 4AC. B is 0 squared minus 4 times A is -9 and C is a whopping 25. When I evaluate that, well, that's a 0. -4, -9 is positive 36. And 1 on Earth is a 36 times 25. 36 times 25 is 900. 900. And since it's a positive number, greater than 0 that is, we know there's going to be another hyperbola. Just like number 5 example I just did before. Now, what kind of a hyperbola is this? Is this going to have a horizontal transverse axis, or is it going to be vertical? Let's find out. So let's make this into a standard form. Let me rewrite it over here. -9x squared plus 25y squared plus 54x minus 200y. And let's, you know what? Let's move this 94 over to the other side right now. Minus 94. And let's group the x's together so we could factor out the coefficient. -9. So we got -9x squared plus 54x. Put the y's together. 25y squared minus 200y is equal to that number we moved over. Now we could make it into a standard form. We got -9 coming out, so what remains inside is x squared. -9 times -6x becomes positive 54. Now we're going to complete the square. Half the 6 is 3, and 3 squared is 9. Knowing that this C9 times the leading coefficient -9, so that's -81, is going to be combined to the right side of the equation. Now over here, the leading coefficient 25 gets factored out, so what remains for the y trinomial is y squared minus, well, 25, if I had 4 of them, that's $100. So if I had 8 of them, that'll give me 200. So that becomes 8y. To complete the square for the y trinomial, half of 8 is 4. 4 squared is 16. Is equal to -94. So, since we gave a 9 and a -9 together multiple is -81 that we must do onto the right side of the equation. And since we give a 16 times the coefficient 25, we multiply them. What's that 25 times 81? 25 times 81. That gives me... why did I say 25 times 81? 25 times 16. 25 times 16. Did I mention when you get to my age, memory goes? There we go, 400. So, they're both positive, so I'm going to combine the 400 on the right side as well. Let's clean this up, simplifying the trinomials into a single binomial. We get -9 times x minus 3 squared, because -3 and -3, when you combine them, is -6. -3 times -3 is 9. Plus 25 times y minus 4 square, because negative 4, when you add them, becomes negative 8. Negative 4 times negative 4 is positive 16, equals the mess on the right side. 94 and 81, that becomes negative, what, 17 and 5? Combine that with the positive 400, that's going to be 225. Yeah. Now, how do I get rid of this 225 and make it into a 1 so we can make it into a standard form? We simply take the reciprocal of the constant 225. So that's going to be 1 over 225. And then we do our distributive property to each of the expressions in a term. So, if you multiply the first expression with the x, the leading coefficient negative 9 reduces 225. How many? I don't know. That's why we have a calculator. So 225 divided by 9. Give me something good. Oh yes, 25, which is a perfect square. Very nice. I like it when it turns out like that. And so, minus the 3 squared. But we have something interesting here. We have a negative coefficient still not going away. We cannot have a negative coefficient as a leading term. We'll have to look at that in a minute. 25 goes into 225. How many times? 225 divided by 25. Going to my calculator. This is 9. Another perfect square. So y minus 4 squared over 9. That's pretty. It's just this one makes me worry right there. And 225 goes to 225 once. So we're almost there. How about if we just simply change these two quotients around? What do you think? What we will end up is, let me bring that over here. What we will end up is y minus 4 squared over, and in fact, since we're here, let's make this into a square form. 3 squared, okay, minus, oh, there we go. That looks more like a hyperbola, but with the vertical transverse axis, since the y comes first. Okay, and the 25, no, wait a minute. Oh, yes. I almost screwed up here. 25 square rooted is 5 square form equals to 1. There we go. Now we got it. Okay, so now we have a vertical. So what's A? Okay, the A always follows the major axes. So A is 3. B is 5. The C? It's going to be a square root of a inverse of a difference. So it's going to be A squared plus B squared. So that's going to be 9 plus, what is it, 25 square rooted? And that becomes square root of 34. What's the square root of 34? I don't know. Approximately, maybe, let's figure this out so we get an idea what it's going to look like on the graph. Square root of 34. It's about approximately 5.8. Alright, we got enough information. And what's my new midpoint? HK. Remember, H follows the X. So the H and the K, the new translated midpoint, is going to be at inverse of negative 3 is 3 and 4. There it is. Now we could graph. Let's make it look like this. So 1, 2, 3, 1, 2, 3, 4. There's the new midpoint at 3 and 4. Okay? From there, we know it's going to be a vertical transverse axis. And so hyperbola is going to open up and down this way. So where are the vertices? Well, it's going to be 3 units away from the midpoint. So 1, 2, 3. So if this was a 4, this will be a 7, I guess. So it's going to be 3 and 7 right there. And it's going to be 3 away down from the midpoint. 1, 2, 3. So right there. So that's going to be 3 and 1. Okay? Now, what about the B's? That will help us define the rectangle, which will help us to draw the asymptotal line. Well, the B is 5 units away from the midpoint. So this way, 1, 2, 3, 4, 5, right there. This was a 3, and so it's 5 is going to be 8 and 4. And if you go 5 to the left, 1, 2, 3, 4, 5. It's going to be negative 2 and 4. So that's going to give us the rectangle. And why do we need that rectangle? So we can draw the diagonal line, which turns out to be the asymptotal line, which will help us to define the hyperbola. What's the function that represents this diagonal line? Y is equal to, when it's a vertical transverse axis, it's going to be plus or minus a over bx. So in this case, y is equal to plus or minus, I hope you could see this, I'll move it in a second, 3 over 5x over here. Y is equal to plus or minus 3 over 5x. That's going to be my function form of the of the asymptotal line. And what will my hyperbola look like? It goes along the asymptotal line, through the vertex, and down. Same thing on the upper side. Around, and continues to go. There it is. So what's my standard form? Well, not this one. It's got a minus. There it is. Sorry about the constant shifting here. And what are my vertices? Right there. 3 and 7 and 3 and 1. What's my midpoint? 3 and 4. Okay. What's my focus? Somewhere but 5.8 units, or square root of 34 units away. So 1, 2, 3, 4, 5. Somewhere here and somewhere down here. But here's my graph. Here's my function for the asymptotal line. And here's my standard form.